How do we find areas of triangles specifically using alternate formulas? Well, we know that the area of a triangle is given by 1/2 times the base times the height. But how can we do that if we're not given the base and the height? Well, one is to look at it in terms of this diagram. If we don't have the height and we have, say, two sides and the angle between them, say side, angle, side, how can we find that height? Well, this height is connected to angle C. It's the opposite side of the right triangle with angle C, and A is the hypotenuse. So that means that we have that h over A equals the sine of angle C. In other words, h is A times the sine of angle C. So when we're using our area formula, we can say area equals 1/2 base times the height, but the height is A times sine of angle C. So 1/2 AB sine C. This is one of the formulas. The important part about this is that angle C is between sides A and B. So that is what I call the sine area formula, 1/2 AB sine C. In the optional videos, you saw the proof of Heron's formula. That was not supposed to be crossing it out. That was supposed to be underlining it. Where if S is the semiperimeter, S is A plus B plus C divided by 2, we can take the semiperimeter times the semiperimeter minus A, the semiperimeter minus B, semiperimeter minus C, take the product of all four of those, and then take the square root. And that will also give you the area. This is more useful when you have side angle side. This is useful if you have side side side. If you don't have either of those, you can solve the triangle a little further, find another side or angle measure, in order to set up one of these two formulas. So if you had angle side angle, well, you could find another side and then turn it into side angle side. So let's apply this. So this is a side angle side. So I'm going to use 1/2 AB sine C. A and B have to be sides that are adjacent and have C between them. So sine C, sine of 38 degrees. This is for the triangle on the left. And I'm going to do that in my calculator. 1/2 times 8 times 10.7 times the sine of 38 degrees. And that's giving me approximately 26.4 square feet. Remember that the units, since we're talking about area, is square feet. Now over here we have 1/2. Multiply the side lengths together, 14 kilometers, 8 kilometers, and the sine of 62 degrees. So we have 1/2 times 14 times 8 times the sine of 62 degrees gives us approximately 49.4 square kilometers. So that's how we can find the area for side angle side. Now if we have side side side, we're going to have to first find the semiperimeter. The semiperimeter is we add all of them up and we divide by 2. We do not divide by 3. We're dividing by 2 to find the semiperimeter. Semi just means half, and perimeter means add them all up. And so the semiperimeter is 28 over 2, or 14. So the formula says we take S times S minus A, 14 minus 13, times 14 minus B, any other side, and 14 minus 8. It doesn't matter what order I put these in, as long as the 14s are all before the side lengths. So now we have 14 times 1 times 7 times 6, and 14 times 7 times 6 is 14 times 42, 14 times 42 is 588. And when we take the square root of 588, we get approximately 24.2 square yards. So that's how we can use Heron's formula given side, side, side. Here we have another triangle, side, side, side. We can use Heron's formula first by finding the semi-perimeter. So it's 1/2 times a plus b plus c, 5 plus 11 plus 14. 5 plus 11 plus 14 is 30, so the semi-perimeter is 15. So we're doing 15 times 15 minus 14 times 15 minus 5 times 15 minus 11. So 15 times 10 times 4. 15 times 4 is 60, times 10 is 600. And now we have 10 squared roots of 6, but typically we're writing this out as a decimal, which would be approximately 24.5 square inches is the area based on Heron's formula. So these are the two formulas that you need to know: 1/2 AB sine C and square root of the semi-perimeter times the difference between the semi-perimeter and each side multiplied together.